Everybody, so you just watched a video on single replacement reactions. Hopefully by now you've realized that this week we're looking at different types of chemical reactions. Yesterday you looked at synthesis reactions and decomposition reactions, and today you're looking at single replacement reactions. With a synthesis reaction, smaller things combine to make a larger compound. Decomposition is the opposite, where one larger compound breaks down into smaller compounds or elements. Okay. Tomorrow you'll learn about double replacement reactions, and early next week you'll look at combustion reactions. Now today you're looking at single replacement. With a single replacement again, you have a reaction between a compound and a single element. And the element may replace another element in that compound during the reaction. Okay. Now there's one other piece that wasn't mentioned in the first video that comes into play with single replacement reactions, and that's what's known as the activity series. So if you look at our periodic table, on the back in the upper right-hand corner is a box labeled activity series. This is a list of metals listed in order from most active to least active. So lithium, potassium, calcium, these are some of your most active metals. As you go down the list, they become less active, okay? Where at the bottom we have gold, platinum, and silver, platinum, and gold. Okay, these are some of your least active metals on the periodic table. So from lithium to gold, the metals become less reactive. Okay, you need to use this list with single replacement reactions, because what happens in a single replacement reaction when you set up the reactants, your compound and your element, if the element by itself is less active than what it could replace, then the reaction simply doesn't happen, and we say that there's a no reaction. Okay? So here's another view of the activity series right here, on the left of the screen. Okay? Again, lithium is the most active, and as you go down the list, metals become less active. Over here, we have a non-metal activity series with the halogens. Chlorine is the most active, iodine the least. Okay? So let's look at two examples, which if we were in class, I would have shown you these in real time. Unfortunately, we're not. Wash your hands. Wash your hands. We're not in class, so I'll show you these just a picture. So in this first example, we have copper wire in a salt water solution, sodium chloride. Now, referring to the previous video, what kind of replacement would this be? Cation or anion? So this would be a cation replacement. It's possible that the copper will replace sodium in sodium chloride. Okay? Now, we have to determine if this reaction will happen in the first place. If it does, we'll end up with copper chloride and sodium all by itself. So if we look at the activity series here, we have to compare sodium, which is right here, okay, with copper. The element by itself, copper, if it's below the element it might replace, the reaction doesn't happen. I'll say that one more time. The element by itself, copper in this case, if it's by itself, or if it's lower, if it's less active than what it could replace, sodium in this case, then there's no reaction. So, will there be a reaction between copper and sodium chloride? No, there will not be. What we say for this one is there's simply no reaction. Okay? Copper might replace sodium. But copper is lower on the activity series than sodium. Copper will not replace sodium, and there's no reaction. So what you would simply write out there are the potential reactants, arrow, and then no reaction. And they literally don't do anything. This is a picture of copper wire sitting in salt water. It just sits there. It doesn't do a thing. Okay? I think when I took this picture, it had been sitting for several days. Not a thing. No reaction. Okay? All right, one more here. We have copper wire and silver nitrate. Okay? Would this be a cation replacement or an anion replacement? Answer that now. Okay, it is a cation replacement again. Copper might replace silver. Okay, so now we need to look at the activity series. The element by itself, copper, and again, copper wire here, is it higher or is it lower than silver, what it might replace? So looking at the activity series on the left, here is copper and here is silver. The element by itself in the reactants is higher, meaning it's higher on the activity series, meaning it's more active than what it could replace. Okay? Copper is higher than silver. So what this means is, in the reaction, copper will replace the silver. Okay? And that's what you see here. This is a solution of silver nitrate, and what's happening, the copper of the wire is dissolving into the solution to make copper nitrate. And the silver from silver nitrate is solidifying as little as silver crystals, and that's here in the reaction, or in the equation rather. Okay, so that fluffy stuff that you see in the picture is literally silver metal forming during the reaction. So this is a single replacement that will react. Okay, so in addition to the simple format of an element and a compound and two elements swapping out, you also have to consider the activity series. Okay, the element by itself in the reactants, if it's less active, like in this case, there's no reaction. If it's more active, like in this case, then there will be a reaction. Okay. All right, everybody, thanks. One more question you want to answer here, and then I'll see you next time. All right, take care.